Hi, I'm Janga Aliminati. I'm the architect for Oracle Fusion Middleware, Applications, and Oracle Public Cloud. In this session, I'm going to talk about Oracle Enterprise Deployment Guidelines for engineered systems like Exalogic, especially in the context of SOA Suite. Before I talk about engineered system deployment architectures, first I would like to explain what are these guidelines and how Oracle formulate these enterprise deployment guidelines or blueprints. So these deployment guidelines are basically the best practices from customer environment, how customer deploy their applications in their data center. So based on that deployment practice, we are trying to come up with a deployment best practices or blueprints for Oracle products, and these blueprints are across the Oracle customer data centers. So it may be with Oracle products or it may be third-party products. So let's look at some of the best practices. So first, before I move on to best practices, let's look at what is agenda today. So today I'm going to talk about deployment best practices and overview, and I'm going to explain different aspects of this deployment best practices, like how the enterprise deployment blueprints are derived based on OTD or OHS or different network segments within the enterprise deployment architecture. For example, I'm going to talk about application to application deployment and also file system layout. First, if you look at the deployment best practices or guidelines, these are mainly, so the first thing, it should be tiered deployment. If you look at the customer data centers are laid out in such a way there will be a DMZ and there will be application tier and there will be a data tier. So each of these tiers are separate VLANs protected with the firewalls and separate regulations. So what we are trying to do is how applications should deployed in this model. Like for example, in the DMZ, you may need only the web listeners like OHS or OTD. But in the application tier, you may need secured applications, like only application tier will host all the applications which are secured. And then data tier, which is most secured. So where you have most secured data elements will be deployed in that data tier. And for example, if the customer trying to access from the internet and they only can reach DMZ, where web listener will take the request and translate that request into application tier. So it disconnect the end user request and initiate the new request to application, and when application process the request, it take the request from application and pass it back to end user. So it means there is no direct connection from end user to your application, so that you are securing your application. For example, end user may inject some virus or some bad things to your application, but since you have your web listener in the DMZ, even if they inject something into your request, and that will be end up in the DMZ where it's no harmful it can do. So this deployment best practices comes with a different protection for customers. So now also, if you look at the way traffic is translated, so end user request is terminating at in the DMZ, and when the web listener trying to talk to, and it's going to only application tier, the next firewall zone or next VLAN, so it's not going directly to database. So we do not allow any request going from one subnet to another subnet crossing two firewalls. In this example, the request cannot go from DMZ to data tier, or request going directly from the data tier to DMZ or to application, or vice versa. So we avoid any communication crossing across two firewalls at a time. And the most important aspect in the deployments that we depend on is high availability. Every layer we introduce high availability. Not only the application deployment we introduce high availability, but also application communication. So when one application talking to other application, that request also completely highly available. So the deployment high availability and the integration high availability. Every request path is highly available. And then configuration of third-party products around this deployment. For example, you configure firewalls, you configure load balancers, and so in that aspect also we provide best practices. For example, for firewalls, we explain exactly what ports need to be open, what protocols need to be open, so that customer applications are much more secured. And then similarly, for example, in the load balancer, there are different things we introduce part of this deployment architecture guidelines document. For example, if your application is encrypted, it runs over SSL. For example, you had to say https://some URL and then 443 port. But what if customer don't type HTTPS? So automatically the port is defaulted to 80, and so that is a very common mistake any customer can do. They don't understand the protocols and port, they only know URL. So how do you protect your application? So we have a recommendation in our deployment best practices how you can avoid the error messages to customer. Rather, take the request from customer, whatever they're typing, and you know what exactly customer wants to mean, so you translate it to that URL so that you can subside user errors. So that way we capture most of the best practices so that customer out of the box, customer is protected with security threats, and customer gets high availability, and customers get scalability. That's the most important thing in the cloud world, and we don't know how many customers is going to access your application. Today it may be 100, tomorrow it may be 1,000, and day after tomorrow it may be hundreds of thousands. So your architecture will withstand with the scalability. So those best practices are part of this architecture. So at the end of the day, what we're trying to achieve is any layer in any network and any server in any process goes down, your end user request will continue. So there is no downtime by bringing down an application or a server. So everything is highly available. So first, look at the deployment guide which we produced based on these deployment best practices. The deployment guide architecture itself is modular. So it means the single guide, but it supports multiple use cases. For example, the table of content, it shows what are the options that customer has. It shows a flow chart. So based on the requirement, customer can pick and choose different chapters in the guide based on their architecture. So it provides, since it is a modular, so the most common chapters are segregated into a must required chapters, and then all the optional chapters are segregated into different chapters so that customer can pick whatever the product they want. For example, so in the TOC they can go and choose all the common chapters and then they pick SOA. And if they want to B2B, they can pick B2B. So they can skip all the rest of the other chapters. If you want everything, you can go one by one. But the guide, the deployment architecture guide, is modular enough to allow customer to implement different use cases, not just one use case, but single guide supports different use cases based on customer requirements. Coming back to the Exalogic engineered system architecture, what we have is we are providing two different deployment blueprints. One is with OTD as a web listener in the DMZ, and one is OHS as a web listener in the DMZ. So if you look at the topology diagram, which is based on OTD in the DMZ, so actually engineered system is a one single rack consists of number of compute nodes. It may be 8 or 16 or 32 based on the capacity of your rack. So everything is interconnected with the InfiniBand network. So it's not like you can't have a real DMZ based deployment in the detached server. So everything is interconnected. But however, we are trying to enforce some of the guidelines what we provide for DMZ environment. For example, here in the OTD is deployed in the DMZ. So if you look at the top topology, so you have OTD, it's a different compute node, and that OTD is a compute node separate from your applications. You see the green line going there, that's called a VLAN. It's a virtual VLAN. So it's how we are achieving is not by partitioning the hardware, just by enforcing as a VLAN concept. For example, when you configure your network and you provide different IP ranges to the OTD compute node versus your application compute node, so that your OTD compute node is isolated from your application compute nodes. If you look at the topology, so what you have there is the request is coming from end user to the load balancer to OTD. And if you look at in the OTD, so up to OTD, it's going regular Ethernet network. So that is 10 gigabit speed you get. but once the request reaches to OTD, and if you see OTD to applications, it's going over InfiniBand network within the rack, that is 40 gigabit speed. Okay, and there is a requirement always one application need to talk to other applications. So that request we always route it through OTD. We are using OTD as an internal load balancer. It's a client side load balancer, and we provide not only the load balancing, but also we introduce high availability to OTD through VRRP, virtual redundant routing protocol. And what happens is you assign a VIP to one of the OTD. If you look at the green line that says VIP 1, and so if the request going from, for example, SOA to OSB, it goes to that VIP 1 URL, and the VIP 1 knows there is 2 instances of OSB is running. If you look at the SOA host 1 and SOA host 2, you have different OSB instances running. So the VIP 1 forward the request to both instances of the 2 instances of the OSB. So what happens if the OTD goes down, right? I mean, still you SOA need to talk to OSB instance. So what happens is the VRRP kicks in. The OTD VIP will be migrated to the other SOA host 2. So you see the grayed out the VIP on the SOA host 2, that will become active. So just like a real hardware load balancer concept we have introduced here, so that you get a load balancing, you get high availability of the load balancing, and so still you are routing within the InfiniBand network within the rack. So your request is not going out and coming back, unlike the regular EDGs or regular non-Exalogic based deployment. We use load balancer VIP as a client side load balancer. So here, once the request comes into the rack, we are making sure it is routed within the InfiniBand to get maximum speed. And then once the request comes to application, from application to database, so you can have 2 options. One is the database may be Exadata. If it is Exadata, you can wire InfiniBand from Exalogic to Exadata so that you get 40 gigabit speed. But you may have non-Exadata, regular rack database. So in that case, you may need to configure E over IB, Ethernet over IB connection from your application to your rack database. So if you look at in this topology, the way the network is laid out is OTD compute nodes configured with 2 types of network. One is to receive the request from end user through load balancer, which is Ethernet over IB network, and then it also configured to receive the request from applications and reroute it back to other applications. So that is IP over IB. So that is within the InfiniBand fabric. So both networks are created on that compute node. And similarly, if you go to SOA host 1 and SOA host 2, it has configured to create receive the request from OTD on IP over IB. That is a 40 gigabit speed within the InfiniBand. And then if application talking to external rack, not Exadata but external rack, then again you need Ethernet over IB network configured on the SOA host 1 and SOA host 2 so that it can connect to the other database outside the Exalogic rack. And if you have Exadata, you don't need Ethernet over IB network. There are other engineering concept we have added here. The first thing, we only routing up within the rack once the request comes into the rack, and when we receive the request from end user, it's coming through OTD. However, in the SOA application deployment, there are requirements to integrate your SOA suite of applications with your internal applications, which may be on the outside the Exalogic rack. So in that case, we also configure Ethernet over IB listener on the SOA suite servers so that you can integrate your non-Exalogic rack applications with your SOA suite in the Exalogic rack. So it is like you get maximum performance when you have applications in the rack, but same application, same deployment, same best practices will work even if you have applications outside the Exalogic rack. Only thing is you don't get that 40 gigabit speed. If you look at the best practices, since everything is routed within the InfiniBand network, and you may have SDP optimization. So when application talking to application, if the request is routed through InfiniBand, you can introduce SDP optimization. So SDP is where when the application talking to other application, it bypass all the TCP/IP layers. I mean, generally, if you know, when the application talking to other application, it has to go to kernel, buffer, and then the system. I mean, then same way the other application has to read same way. But when you use SDP, it's direct socket between application to application. You don't go through that buffers or kernel translation. So that you get another layer of performance boosting there. I mean, in this version we have not introduced SDP yet, but these best practices or architecture that we are publishing fully supports SDP optimization. We are also supporting OHS based deployment. For example, in the earlier topology, I mean, you have OTD is in a separate compute node. Because of the security, you put it on a separate compute node. Of course, if you have a virtual environment, it can be on a separate VM. You don't need a separate physical compute node. So you know, I mean, OTD running on a separate compute node, it's kind of overkill, but you get a maximum security there. I mean, if you are worried about dedicating your compute nodes for OTD, then you can choose OHS. So if you look at this OHS topology, what you have here is the OHS is outside the rack. So it's in the pure DMZ deployment outside the rack, and it's on your conventional hardware. And then when the request comes in from end user, it goes from load balancer to OHS. OHS translates the request to your application in the rack. So you have additional hop in the DMZ, and but you get a security, and you don't need to dedicate your compute nodes, and it is aligned with your regular conventional application deployment in your data center. So both are we are publishing and providing best practices. Both of these topologies are fully tested and documented in our enterprise deployment guidelines for Exalogic SOA Suite. So what happens here is, I mean, the request coming to OHS in a Ethernet over IP with 10 gigabit speed, from OHS to your application also going to 10 gigabit speed because it's Ethernet over IP. However, when the application talking to other application, for example, SOA talking to OSB, just to go to earlier example, and that request now is not going through OHS, because if it goes through OHS, then you are going out from InfiniBand to Ethernet over IP network, and then coming back to InfiniBand network. So that will you lose the InfiniBand optimization there. So that's the reason what we did is we have OTD configured as a client-side load balancer in SOA host 1 and SOA host 2. So you have active passive. So what happening here is when SOA talking to OSB or OSB talking to SOA or any other application to application goes through this OTD as a client-side load balancer. So the VIP you assign to OTD acts like a virtual endpoint, and then all the requests are routed through that virtual endpoint. If for some reason SOA host 1 goes down, you still have a SOA host 2. So if the SOA initiate the request, and it still goes to OSB on SOA host 2, because the OTD client-side load balancer now is activated automatically on SOA host 2. So you have a highly available client-side load balancer configured, and all of your application to application routing is happening through OTD within the InfiniBand network. So I mean, we are taking advantage of InfiniBand optimization through this configuration. And similarly, I mean, as I said earlier, SOA need to be integrated with your internal applications. So for that, you can integrate a UORIB listener, which you can configure on SOA host 1 and SOA host 2, or on OTD itself. OTD can have a listener on InfiniBand side on IP over IP, and OTD can have listener on Ethernet over IP. So that can also act as a client-side load balancer to receive the request from your internal network. So, and this topology, the best practices you see here exactly same as OTD based topology. Only the difference is in the earlier topology you have OTD within the rack. Now in this topology you have OHS outside the rack. And these best practices that we are recommending, not just for Exalogic, even for any application deployment in customer data center. And so we are trying to mold all those best practices into Exalogic engineered system, and without deviating the customer requirements there. So If you look at some of the other performances or optimizations that we did as I said, in the OHS based deployment, you don't need to dedicate the compute nodes. You can have all the best practices and there is also additional benefit that you have is, for example, in some of the industries, especially biotech industry, every request which goes from the web listener to application will be inspected. So that request is routed through another secured system, and where it does packet inspections. So it makes sure the request from OHS to application is safe enough. So this topology perfectly suits for that, because when you have OTD based topology, you can't route the request from OTD to application through another system outside the Exalogic, because that defeats the purpose that we talked about. So in case of OHS, you can do so without degrading the performance, because OHS is still going through the outside the rack. So before the request reaches to the rack on an application, and it can route it through the other security system. That biotech industry generally enforces that rule. If I look at the networking side, especially the application to application routing, I talked about different network interfaces that we create. For example, so Ethernet over IB, which receiving the request from the load balancer or end user, it has to be exposed to the DMZ or load balancer, because that IP need to be visible from that network. So it should be a DNS enabled network. And so when application once the OTD or OTD receive the request, when it translates the request to application, that is within the rack. So now you have option, either you can have DNS aware IP address, or you can have an internal IP address. For example, if you use internal IP 127 or something, and you can assign it to the OTD or the other compute nodes, but you have to translate that IP to name through etc host. But if you can use, you have the Ethernet over IB typically assigned to bond 1 and :1 or :2, and IP over IB addresses are typically assigned to bond 0, which is you can extend it to bond 0 :1, bond 0 :2 if you require to create multiple virtual IPs or multiple endpoints. So for this, when you configure your Exalogic, if you want to have a DNS enabled routing, and then you can have actual like a 10.10. Whatever your DNS IP, you can assign it to bond 0. So that still, even though it routes within the InfiniBand network, but you don't need to depend on etc host, and through DNS translation it knows when the request going from one compute node to other compute node. And so similarly, Ethernet over IB also, typically Ethernet over IB interfaces are accessed through systems outside the rack. So you need external IPs, which are DNS enabled IPs. So that way, you can reduce your DNS dependency, or if you don't want to depend on etc host, you can use your DNS based IP addresses. And as I said, every communication path in the Exalogic, within the Exalogic, is highly available, which using Ethernet over IB or with an IP over IB. And sometimes we have different protocols like HTTP, LDAP. These are routed through OTD. But if you have other protocols like a T3, the OTD doesn't support that protocol. But what we did is to ensure high availability within the system without going through an external load balancer. What we did is we introduced cluster concept within the T3. So T3 communication now, when goes to one application to other application, it can use cluster address within the WebLogic server. So whatever the cluster you create for your application, you can use that cluster address, so that WebLogic subsystem knows who are the members in that cluster, and it can translate the request to different cluster members. So you have that capability, and so at the end what happening is you get complete high availability, complete redundancy for your application stack within the Exalogic rack. Go through the virtual IPs which we use. For example, in the topology, what we have is on the external, when the end user sends the request to SOA, or when end user access to SOA or any other SOA suite of applications, you have an external load balancer URL, which is soa.mycompany.com, for example, right? You can use any company specific name, but you can use, in this example we used mycompany.com as a company name. So soa.mycompany.com, which is SSL enabled VIP on the load balancer, it receives the request from end user to load balancer in an encrypted fashion, and it will offload the SSL at the load balancer level and transfer the request to the web listener in the DMZ, which may be OHS or OTD, in a non-SSL mode. So what we assume is your data center is protected enough, and within your data center everything is protected, so you don't need to encrypt, which encryption adds additional overhead for encryption and decryption. So majority of the customers, if their data center is isolated and it's protected within the data center, then they want to run non-SSL fashion. However, that is an example in the EDG, but you can change that. If you have any concern about your data center, you can further encrypt your communication path from the load balancer to OTD or OHS or OTD to your applications, if needed, from applications to your database. So everything end to end you can have encryption. But based on majority requirement, so we are offloading SSL at the load balancer level, and every communication within your data center we are making sure it goes in a non-SSL fashion to get maximum performance and to avoid encryption decryption. And we also have soainternal.mycompany.com as a VIP in the load balancer. That is mainly if you have any web services integration. So if you have a web services integration from non-rack systems to systems SOA or Web Center or SOA or OSB in your rack. So if you have any intranet integration through web services or any HTTP based integration, or if your administrator wants to do some config changes through SOA console, then they can use this soainternal.mycompany.com, which is on the load balancer. You can create an OTD, but it's not going to add anything because the request is coming from outside the rack on the Ethernet side, and if it comes through load balancer, you can simplify the configuration, so you don't need to create too many VIPs on the OTD. You can use load balancer for this purpose. And you also have, if you have a LDAP systems running, then you can use OTD listener for your LDAP as well to virtualize your LDAP instances or your OPSS configuration going through your LDAP servers. We also heard number of times people talking about partitioning. So they say, in the physical deployment, you can have edge partition where you can partition OTD compute nodes into different network. Edge partition is a hard partition, and if you have a hard partition, then you have you have to enable, for example, if you create the web host 1, web host 2 into the different hard partition, then you have to add your SOA host 1, SOA host 2 to the partition of your web host 1 partition. But it's not like a web host 1, web host 2 talking to SOA host 1, SOA host 2. So you have a both bidirectional communication for internal load balancing as well. So what happens is then you have to add both OTD instances also into the another partition on the application side. So you create multiple partitions, add everybody into every partition, or if you don't create a partition, it's the same thing. So that's the reason we are not recommending edge partition or a hard partition. Instead, we are asking to create a network virtual partition by assigning a different network IPs to your compute nodes. For example, OTD, you are assigning the IP address to which is visible to DMZ, and when somebody trying to access, they can only through IP address they can only reach that web host 1 and web host 2, whereas your internal SOA host 1, SOA host 2 either running only IP over IP addresses which cannot be accessible from your DMZ or outside, or you can have Ethernet over IP only internal facing, so that it cannot be accessible from outside. So that is the way we are mimicking the partition here, not through hard partition. And next topic I want to talk about is a file system. So in Exalogic, the file system layout is one of the important thing to get better optimization for your application deployment, especially to handle your lifecycle operations for backup and recovery, or when you have a server migration, whole server migration, you have different requirements in the how you lay out your file system. You may have a shared disk, you can have your applications there. However, to get a maximum performance and same time to optimize your lifecycle operations on your deployment, you have to follow certain guidelines that we prescribe for the deployment file systems. So for example, I want to show this topology, and in this topology what we have is when you partition your file system on ZFS in the Exalogic rack, So what happens is you create a project. For example, it's a SOA Suite you are doing. In this topology, I'm showing IDM as an example, but it's exactly for SOA Suite. So you create a SOA Suite file system. Under the SOA Suite, what you have is, I mean, you have to have a file system, read-only file system, where you lay down your binaries. I mean, when you're installing binaries, it may be read-write, but once you install the binaries, you can make it as a read-only, so that none of the runtime process can write to that file system. It's a read-optimized. It's read-optimized, and only during the runtime the processes will read things from that file system. Then you have read-write file system, which we call it as a UO1 Oracle config, and whereas read-only is UO1 Oracle products. And in the read-write file system, it's optimized for both reads and writes. So it means you have your config files there, and if you generate some runtime data, you can persist in that file system. That's a read-write. So both this UO1 Oracle config, UO1 Oracle products, both are shared across all the compute nodes. So you create this file system on a ZFS, but mounted across all the compute nodes, and the actual file system maybe is a whatever the mount point you have, but those are two different mount points, and you mount it to each compute node through UO1 Oracle config, UO1 Oracle products. And apart from these two mount points, you also need third mount point for your file system. That is UO2 Oracle config. So that is where your runtime processes read and write. So it means what happening is, if you have a UO1 Oracle config, and if you start all of your processes, for example, you may have a SOA Suite scaled up multiple compute node and Web Center scaled out in multiple compute node. When you try to stop all of these processes at a time, all of these processes are competing with one mount point, which is UO1 Oracle config. You don't want to do that, because if everybody is competing to same mount point, it will introduce contention. So it will slow down your startup process, or it will slow down whatever the operations you are doing. Instead, what we do is we mimic local file system on the ZFS. The way we mimic the local file system is we create UO2 Oracle config. So you can create the mount point, and that mount point is mounted to UO2 Oracle config. So this file system we create node specific. It means SOA host 1 will have a UO2 Oracle config. SOA host 2 will have a file system on the ZFS, and that is mounted only to SOA host 1 node through UO2 Oracle config. And similarly, SOA host 2 also have its own file system on the ZFS that is also mounted to UO2 Oracle config on the SOA host 2. So the path looks same, so that your application, there is no mistake for your application to assuming these local paths. So path looks same, but the file system on the ZFS, on the shared disk, is different. So it is, we call it as a node specific file system. So what happens is, for example, if you are running your JMS server, right? You have a JMS, WebLogic JMS, you use file system persistency. If you use file system persistency, your file stores, your JMS stores are in your file system, which is on the domain directory on a shared disk, not on the local file system. So that if the SOA host 1 goes down, so the UO1 Oracle config is mounted to SOA host 2 also. If your JMS persistent store is UO1 Oracle config, that can be visible from SOA host 2 also. If it is part of the UO2 Oracle config, that is mounted only to SOA host 1. So if you write any JMS store there, and if you want to migrate the server in case of node failure to SOA host 2, you cannot read the transactions done through SOA host 1. You can bring up the SOA host 1 SOA server on SOA host 2, but you cannot access the JMS store. So that is the reason whatever the artifacts that you want to share, it goes to UO1 Oracle config domain directory, which is on a shared disk and mounted across all the compute nodes. Whereas your pure runtime processes will be started from UO2 Oracle config, that will be visible only from locally. Since every application is cluster redundant, so if that node goes down, it's okay if that application cannot be accessible, and you have a SOA or OSB on the SOA host 2 or SOA host 3 based on your requirement, and it can be started from its own local file system. So that's all I have for today. So we talked about what is enterprise deployment best practices or blueprints, and I also explained how Oracle prescribing these best practices and how we are deriving these best practices. And then I showed you the topology, Exalogic enterprise deployment topology based on OTD, and also enterprise deployment topology based on OHS, and engineered for engineered system, and so the architected for engineered system. And I also talked about different networking interfaces that we configure part of this deployment, and at the end I talked about file system. I hope you enjoyed, and this is informational for you, and if you have any questions, please feel free to refer enterprise deployment guidelines document. Thank you.